Good morning, children. We proceed on to chapter 7, Financial Mathematics. Money is a day-to-day transaction, isn't it? We get loan, we save money. In every case, we are paying money, not all at a time. Mostly, we pay monthly or quarterly or half-yearly or annually, not for a single year, but for 10 years, 15 years, 20 years, like that. This chapter, we are going to learn about payments that we make. The very first word, annuity. What do you mean by this word, annuity? The word annuity deals about equal payments. Either we make it or we receive it. So, equal payments made or received at equal intervals of time. It's good that we know certain words. Periodic payment. The word periodic tells us regular. So, amount that we pay. Payment tells amount. Periodic tells regularly. So, what is periodic payment? Amount that we pay regularly. Or in short, amount of regular payment is called periodic payment. Regular, I said. So, when should I pay? Every month I can pay, or every quarter I can pay, or every half year I can pay, or every year I can pay. So, when I pay every 3 months, I call it quarterly. When I pay every 6 months, it's half yearly. When I pay every year, we call annually. This time limit between two successive payments, or I can say the consecutive payments or the next payments, that we call payment interval. The next idea, for how many years are you going to pay? The time between first and last payment is called term. For example, you are taking an insurance policy and you are about to pay 20 years. The term I call 20. If you are going to pay it for 30 years, the term we call 30. So the term is nothing but time between your first and last payment. Now, how are we going to calculate it mathematically? Annuity, we divide into two major ideas. Ordinary annuity, annuity due. What do you mean by ordinary annuity? I get loan. Supposing I am purchasing a house or a flat or a car or any other vehicle. I get loan, and every quarter or every half year or every year I am paying the installment that we call installment made at the end. So notice the word end, that is important. As you are reading the question, check whether the problem is about annuity paid at the end or annuity paid in the beginning, because we have two different formula for that. So if we pay at the end, we call it ordinary annuity, and if we pay every beginning or every term beginning I pay, that is called annuity due. So installments made at the end is ordinary annuity, whereas the installments made in the beginning we call annuity due. For annuity at the end, I can say example housing loan or vehicle loan, like that. For annuity due, I can give you an example, life insurance. So, policies, we make a beginning of each quarter or beginning of each half year or beginning of every year. Beginning doesn't mean January. Beginning means beginning of your policy. When you start with, that is called beginning. Saving scheme. So this is the month of October. I am starting to pay from October. So every October, today is say 20th. So every October 20th I am paying, or October 20th, then November 20th, then December 20th I am paying. So today I start paying from today. That is called annuity made in the beginning or annuity due. In all the saving schemes and life insurance policies, we adopt this annuity due. Now, there is a special annuity called perpetual annuity. What do you mean by this word perpetual annuity? Perpetual annuity is an annuity whose payments are paid continuously. The amount of perpetuity is undefined. As the amount increases without any limit as time passes on. Now we will learn formula for each of this. Annuity, when I want the amount, the formula is A by I 1 plus I power n minus 1. If I want the present value of the loan, it is A by I 1 minus 1 by 1 plus I power n. The same formula, how shall I change if it is annuity due? The same thing we do because it is paid beginning. We will include 1 plus I extra in the formula. Here it is A by I, whereas here A by I into 1 plus I. The bracket, there is no change. It is the same in both the formula. In amount, it is 1 plus I power n. Whereas in present value, it is 1 minus 1 by 1 plus I power n. For perpetual annuity, we get it when this present value, as I increase the time, that is as n tends to infinity, we say. Now n tends to infinity, this particular part will become 0 because n is infinity. The denominator is a huge amount. So 1 by a huge quantity will become 0. So this part goes, I am left with only A by I. So let us remember amount, present value. As we read the question, let us remember to underline certain words. Check, is it annuity at the end or in the beginning? Is it amount or present value? Amount, use A formula. Present value, use P formula. If it is beginning, we use this. If it is end, we use this. And if it is perpetual annuity, we are using P equals A by I. Now, all these formula are defined for annual payments. Suppose, if I am paying half yearly, wherever n is coming, half yearly means I am paying 2 times in a year. If I pay 2 times in a year, n becomes n into 2. Whereas the I, interest rate, it becomes I by 2. So when I pay half yearly, that is 2 payments. N tells me 2 into that value, n. I tells me I by 2. If I pay quarterly, n will become 4 into n, whereas I will become I by 4. So we generalize the formula. When the payment is made k times a year, k times. How many times I pay in a year? I call k. If so, in the formula, wherever n is coming, put n into k. And wherever I is coming, put I by k. And this exercise is a very simple and easy exercise provided we are thorough with the 5 formula. Exercise 7.1, question number 1. Find the amount of ordinary annuity of rupees 3,200 per annum for 12 years at the rate of interest of 10% per year. As we read the problem, it is ordinary annuity and my question is amount. So amount for ordinary annuity, we recall the formula A by I into 1 plus I the whole power n minus 1. I need to identify A, I, n from the question. A, how much we pay? 3,200 per annum. Per annum tells every year. Per annum is yearly payment. So A is 3,200. N tells me how many years. So it is 12. So N is equal to 12 years. I tells me rate of interest. 10% tells 10 by 100. That is 0.1. As we know ANI, let us substitute in the formula. A equals 3,200 divided by 0.1 into 1 plus 0.1 the whole power n. What is n here? N is 12 minus 1. As we check 3,200 by 0.1, it is 32,000 into 1 plus 0.1 is 1.1 whole power 12 minus 1. What is 1.1 whole power 12? They have given in the question 3.1384. So we just substitute from the question. As we simplify, we get rupees 68,428.8. Approximately, it is rupees 68,429. So, when we pay an annuity of 3,200 every year, at the end of 12 years, we will get rupees 68,429. Second problem, if the payment of rupees 2,000 is made at the end of every quarter for 10 years at the rate of 8% per year, then find the amount of annuity. The word at the end tells us amount formula A by I into 1 plus I the whole power n minus 1. We need to identify what is AIN. What is A? Payment of rupees 2,000. So A is rupees 2,000. For 10 years, so N is equal to 10 years, but the word quarter tells in a year there are 4 quarters. So 10 into 4 quarters. Remember, annually I keep as it is, but quarter comes per year 4 quarters. So 10 into 4, N value is 40. What is the rate percent given? 8. 8% per annum. This is for 1 year. But we are paying quarterly. Here I multiply by 4, whereas here I divide by 4. So this is quarterly. So what I get? 2%. 2 by 100, 0.02. So let us remember, whenever it is quarterly payment, years multiply by 4, whereas rate of interest divide by 4. Let us substitute in the formula. A equals 2000 by I value 0.02. 1 plus 0.02 whole power 40 minus 1. 2000 by 0.02, 1 lakh. 1 plus 0.02 is 1.02 whole power 40 minus 1. Let us refer back to the question. 1.02 power 40, the answer is given in the question, which is 2.2080 minus 1. Use your calculator. We shall subtract 2.2080 minus 1. Multiply by 1 lakh. We get 1,20800. So the amount received is 12800. Problem number 3. Find the amount of ordinary annuity of 12 monthly payments of rupees 1500 that earns an interest at 12% per annum compounded monthly. Look at the words. Ordinary annuity. The formula is A by I, 1 plus I whole power n minus 1. Payments rupees 1500 tells me A equals 1500. N. What is N given? 12 monthly payments. So N is 12 and the payments are months only. Interest rate 12% per annum given. So 12% per annum, but we want monthly. So 12 by 12 monthly. Or I will say it is 1 by 100, that is 0.01. 12 monthly payments tell me N is 12 months. But this is given per annum. Per annum tells me yearly. So divide by 12. Why do you divide by 12? 1 year is having 12 months. As I divide, I get 1%. That is 1 by 100, which is 0.01. Let us substitute in the formula. Capital A, that is amount, equals A 1500, I value 0.01, 1 plus 0.01 whole power 12 minus 1. 1500 by 0.01. It is 150000. 1.01. 1 plus 0.01. We will write 1.01 power 12 minus 1. 150000. 1.01 power 12 given in the question 1.1262 minus 1. Subtract and multiply. As we simplify, we get the amount is rupees 18,930. Question number 4. A bank pays 8% per annum compounded quarterly. Find the equal deposits to be made at the end of each quarter for 10 years to have rupees 30,200. Is A given in the question? Find the equal deposits. So small a is not given, so that is the question. What is N? 10 years. But see the payment. Is it yearly or quarterly? The word quarterly given. So that tells me 10 into 4, 40 quarters. So now that n is 40. What is amount given in the question? We are paying such and such an amount to have 30,200. So amount received is 30,200. What is the percentage given? 8% per annum. Per annum tells me divided by 4 because we are doing quarterly. So in a year there are 4 quarters. So 2% tells me 2 by 100, that is 0.02. What is the formula given at the end? So whenever the deposits are made at the end, the formula is A equals A by I, 1 plus I whole power n minus 1. What all we know in the formula, let us substitute. A value 30,200. Small a we don't know, write as it is. I is 0.02. 1 plus I, 1 plus 0.02 whole power n is 40 minus 1. Cross multiply 30,200 into 0.02 is A. This will become 1.02 power 40 minus 1. 30,200 into 0.02. 604 is A into 1.02 power 40 given in the question 2.2080 minus 1. Or what is A? 604 divided by, subtract, bring it down. It is 1.2080. Divide and find out what is A. This is the equal deposit to be made at the end of each term. So equal deposit is the question. Small a we need to find out. So the equal deposit to be made is 500 quarterly to get 30,200 at the end of 10 years.